Okay, number 12 for the Practice Provincial B is the last question in the no calculator portion of this particular exam. Alright, question asks us, determine the ratio of cos A. So cos A is here. There's angle A. Okay. Now, this particular problem requires us to remember what is the definition of cosine. Well, in class we learned the following: SOHCAHTOA. Okay. And the one that's most important for this particular problem is CAH. And this says that the cosine of an angle, theta, is equal to the adjacent side divided by the hypotenuse. Alright, so back to our triangle. So we need to know, so the cosine of angle A is adjacent divided by hypotenuse. Well, this happens to be our adjacent side, which we don't know. We'll call it x. So we can write cosine of A is equal to adjacent side x divided by my hypotenuse, which is 3. Okay. Remember, the hypotenuse is always opposite of this angle. Okay. So wherever this 90-degree angle is, directly across from it is going to be the hypotenuse. That's how we know the hypotenuse is 3. Now, how do I calculate the adjacent side? Well, since this is a right triangle, we can use Pythagoras' theorem. A squared plus b squared equals c squared. So we can use Pythagoras' theorem, remembering that a squared and b squared are just the short sides, and c squared is the hypotenuse. So we'll make a squared 2 squared, because it's one of the short sides. We'll make the other short side, we already made it x, and c squared is going to be 3 squared. So now we get the following. 4 plus x squared equals 9. I'll bring the 4 over. So we get x squared equals 5, or x is equal to the square root of 5. Since we don't have a calculator, we can't actually evaluate what the square root of 5 is. So we just use it as that. So we can write then that cosine of A is equal to x, which is the square root of 5, divided by 3. That answer happens to be B. And you can probably hear the train. I live beside some train tracks. Alright. Checking the answer. For number 12, answer is B. Alright. So this is a combination of using both SOHCAHTOA. I'll highlight that in red. So using SOHCAHTOA in combination with Pythagoras' theorem.